G'day and welcome to Cloud Cartographer. It's been a big week this week with reInvent over in Las Vegas. There was a really cool announcement that I wanted to take a look into, and that was the announcement of IPv6 support. And this is just one of many cool announcements that I'm going to be taking a look at over the next couple of weeks. But IPv6 support, so I think this is great. I've been waiting for this for several years, and it got me thinking. I think one of the main inhibitors to people adopting IPv6 is actually usability on the public cloud. So this is a great first step for people to start taking a look and experimenting with IPv6, and then I think we'll see it distribute out as major hosting platforms, public cloud platforms start rolling it out. But it got me taking a look, and I'll show you how we can set up VPC and do some routing in a few minutes. But the announcement, I'll put a link in the video, but you can take a look at the VPC IPv6 routing. Now, there's a few details in here. One is that it's only supported today in US East 2, which is the Ohio region. And there's a couple of cool little features in here. You can run it dual stack, which for those of you that don't know what dual stack is, it means you have both an IPv6 and an IPv4 stack on your VMs. Now, I haven't played with any of the API integration right now. I'm just going to click through the console and actually show you how to get something up and running so you can start playing with it yourself. Now, the other cool thing that I'll show is egress-only internet gateways. So one of the major differences in IPv6 is that there's no NATing, which is something a lot of people hide behind in IPv4. So every IPv6 address can be internet routable if it's in the global unicast block. So obviously hiding behind a NAT no longer serves as a security measure. So one of the things that they've done to counteract this is egress-only internet gateways, which means you can create outbound connections to the internet from your VPC, but no inbound traffic will be allowed. So just something to think about there, and I'll show you how we can plumb that in. Now, the other thing was I went and took a look at Azure. Does Azure support IPv6? And the answer is yes, it does. It does exactly the same as what Amazon have announced this week, AWS have announced, so that is there. The disappointing thing is that Google Cloud does not yet. So GCP networks do not support IPv6 at all from their documentation. I'm sure that's something that will be changed soon, but as of today, that is not the case, from what I can tell here. So let's dive into a quick demo of how we're going to set this up. So here I have, I'm in Ohio, the Ohio region, US East 2, which is the only region that supports it. I'm going to go through a whole use case of setting up IPv6 addresses, setting up the routing, and then I'll go and launch a VM and we'll attach an internet address to it, an IPv6 internet address to it. So here we go. Let's go ahead. So we've got this VPC here. What I'm going to do is edit CIDRs, and I'm going to ask for an IPv6 CIDR, and this is going to give me an IPv6 CIDR that's automatically associated. So here we go. We've attached that. You can see it down here. Great, that's step one. Another cool little thing we may want to do here is let's just have a look at this block. I've just got a lookup tool, public lookup tool. So it is Amazon EC2, and it looks like they have a /32 here. Fantastic. So I have a public address block from Amazon, and I would get a /56, which is a whole bunch, 2 to the 56 addresses. I think that's 256 /64s, each with 2 to the 64 addresses, which I had a calculator here, so 264. If you do /64s, you get that many addresses. Lots. Probably enough if you're using Kubernetes. You're going to have enough for container pod IPs, I should say. Okay, so we've attached a block. Now what we can actually do is, like IPv4, we need to create subnets. So we're going to just go and auto-assign. Let me have a look at the lowest numbered subnet here on IPv4. I'm going to go and add a 00/64 to this guy. Let's make sure that that's happened. Did I not add it? got to click OK. There we go, got one. I'm going to go through all these 0, 1, colon. Okay, so I'm assigning /64s to each of these subnets. There's one per AZ here. Now the other neat thing, and I'll leave it at the moment, but I did notice this, that the routes, there's no default route for IPv6 by default, but there is one for IPv4. So let's go ahead and just drop one in here for now, so we don't forget to do that later. Now the notation for a default route is :/0, if you're not familiar with working with IPv6. So I've added a static default route for IPv6 via that standard internet gateway. Let's also, while we're here, we'll create an egress only. Okay, so I'm going to create that. That is created. Now what I could do here is, if I want to route externally, I should be able to do something like this and change it to the next hop be the egress only internet gateway. So just for, we'll leave it as the standard internet gateway at the moment. Okay, at this point I believe I should be set up. I'm going to pop over here and just, I've got a Terraform here to create an instance. Just use a standard. Pop over and wait for this instance to arrive on the EC2 side. Nothing there yet. Okay, still creating. Okay, here we go. It's coming up. So you can see this new field here, IPv6 addresses. I do not have one. One interesting thing about that is we actually need to go and actually tell it, because in my Terraform I don't know that I have a way to tell it I want an IPv6 address yet, but let's just go in here and assign a new one. We're just trying to do a proof of concept here to show you that it does actually work. So we've got an address here. Okay, great. You should see it down here. Fantastic. And now let's assume this is okay. SSH. This guy. Alright. So let's have a look. Right, so I did assign that address. If you didn't assign it before the machine booted, I think you need to reboot it. This is using autoconfig to pick up an address. Now, if you're familiar with addresses in IPv6, I have a link local address, you can see from the scope, and FE80 actually signifies a link local, which is only a point-to-point connection on a link. It's used for things like autoconfig, neighbor discovery, and a bunch of other services in IPv6 world. This is my IPv6 real public address. So that's been assigned from the /64 of this subnet. Now I should just be able to, actually let's take a look, netstat -a inet6. Now, for those of you not familiar with netstat, I think we need to pass in the address family for most distributions. So here's our next hop, which is actually on the other side of this link local. Okay, at eth1 0/0 here's our loopback on IPv6. Here's our internet interface address. So we're good to go here. So I should be able to do, if I do a host, www.google.com, I do actually get a quad A record here, and if I do a ping6, www.google.com. Right, so we're actually hitting www.google.com on IPv6. Ping6. There we go. Just to prove that we're doing that there. Now, one other thing, and we'll go back to the VPC. So you remember that the default route for the route table on this VPC was pointed to the internet gateway. Let's go ahead and break that. We'll get this ping running again. We'll prove that this route is actually in use by breaking it. You should see it get updated. Booyah. So my pings are broken, and I'm going to go and actually push the traffic through that egress only internet gateway. And as I mentioned earlier, that is kind of a stopgap measure to keep yourself safe when moving to IPv6. Kind of a nice catch-all there. So I've added it back, and obviously this is from a VM going out, so that is enabled. I wanted to show you my IPv6 and ping that address from here, the VM address, but unfortunately I got a new router and it doesn't support IPv6, so that's a bit of a bummer. Otherwise I would have shown you pinging into it. But what we've done here is we've created, we had a VPC, I've attached a IPv6 CIDR block to that. I've then cut it up into /64 subnets, created a route, created an egress only internet gateway, and then launched an instance and assigned an IPv6 address to it. And then I've done a ping 6 out just to prove that I have IPv6 connectivity from a dual stack. Remembering it's got an IPv4 address and an IPv6 address. And yeah, it all works as advertised. So thanks for joining. This was a lot of fun. Shout out to Joe Bader from earlier today. We were tweeting about this. I wanted to get my hands dirty and see how it works. So I had a lot of fun putting this together. Anyway, thanks for watching. Cheers.